pretty last of it. Alright, they start with Pascal's triangle. Do you know Pascal's triangle at all?
Yeah.
Right? So 1, 1, 1, 2, 1, right? 1, 3, 1, 1, 4, 6, 4, 1. Okay, so you guys have that down, right? Okay. But there's an importance to this when it comes to polynomial expressions. And what we want to be able to do is we want to be able to expand out binomials, and we can use this to help us with our coefficients of the binomials. So what I mean is this: if I start by looking at this guy right here, if I go x plus y squared, okay, and I FOIL it up, I'm going to get x squared plus 2xy plus y squared. Okay, so what are the coefficients here? 1, 2, and 1. Okay, let's expand this now.
X to the third.
X to the third.
Plus
X, 2xy squared.
no, 3x squared y.
Okay, hold on a second. Let's just focus on the variables first, and then we'll come back and do the coefficients.
X squared y. Plus x y squared plus y cubed.
Well, and then there's E3s for the x. For the x
1,
squared y.
3, 3, 1, 1. Right? You guys have done this before? Did you? With the rest of you guys?
Well, I learned it right off.
Okay. So let's do this one more time. All right. X to the fourth plus
4x squared.
Okay, again, let's go without coefficients for a second.
X cubed y.
X cubed y, x squared y squared,
Oh, and then
X
cubed. Or
x y
xy
cubed plus
xy squared.
What?
No, shouldn't it be? No, never mind, that's right.
4, 3, 2, 1, 0.
Yeah.
0, 1, 2, 3, 4.
And then, yeah.
You follow this?
Yeah.
Okay. So basically, it's just a pattern, right?
And then it's 1,
So that's
4,
1,
6, 4,
4, 6, 4, 1. Okay, that's great. Now, how does this tie into what we're doing right now? So the coefficients can also be found by using combinations. Okay? So it's not as bad as you think. All right? Because what happens here is this: first of all, that's the largest value of your exponent, right? Basically, that's the degree of your exponent. Okay? So just focusing on coefficients now. Watch what happens here. 4C0, 4C1, 4C2, 4C3, 4C4. You follow that? So basically, all I'm doing then is I'm going by which, the y value is the exponent. Whatever this value is. Now there's an easier way to do this. I'll show it to you in 1 second, okay? But do you understand that 4C0 is 1, 4C1 is 4, 4C2 is 6, 4C3 is 4, 4C4 is 1. Okay? So now if I asked you to do this, and let's say I wanted, but I only wanted the 7th term. Okay, so I'm asking you to figure out what the 7th term is at this point. So, okay, go ahead, let's see what you got.
Well, just going by that combination, it'd be 15C6.
15C6, yeah,
It'd be 7 minus 1 because you start at 0.
yes, exactly. And then
So you'd have 6y.
y,
Y to the power of 6.
6, yeah,
And then
X9.
Yeah,
Yeah.
that's fine because you're small.
okay, this is a lot better than I thought. You guys are way ahead of the game here. Okay, so these have to add up.
Yeah.
They have to add up to give you the 15 right there. Okay, and then that's absolutely correct. Okay, so the actual, now I do it different, I think. Does somebody have their formula sheet handy?
Yeah.
So on your formula sheet, they write it like this.
I thought it was in your language.
Stuff now.
It's like hieroglyphics or something.
Okay, so using this, using this thought process then, okay? You did it exactly how I wanted you to. If you want the 7th term, the k value for this is 1 less than it, right? Because k plus 1 is got to equal 7. So therefore k is 6, okay? This value right here is b to the k, or y to the k. I use y here, but b to the k, right? And then this value is whatever your term value is minus your k value there. So that's basically it. Now there's a couple different ways in which they throw a couple curveballs at you, but for the most part, you guys have the tough part down already. Okay, let's look at let's go through working example 2. Okay, so this is you need to follow along. Maybe not so much as the book writes it, but as I'm doing it, because it's going to make it a lot easier. So there's 3 ways in which they can ask you a question for this. They can say, find the 5th term of, okay, which we just did. The second way they can ask the question is, find out when a is got an exponent of 5. So you use a pattern to find it out, okay? And then sometimes they'll ask you what the constant term is, which means the variable doesn't exist anymore. All right, so there's 3 ways in which they can ask this on the exam. So we're going to look at all 3 of them. We're going to work example 2. Okay, so first thing says expand, use binomial theorem to expand 3a minus 4b to the 5th. So here's a couple ways in which we can look at this. 3a minus 4b, that's all to the 5th, right? Now, first things first, odd terms. So when the k value is an odd number, you're going to end up with a negative. So every second term is going to be a negative. But I'll show you that as we go, but it's just something that you want to keep in mind. All right, so the very first term of this, okay, is 1, 3a to the 5. Right? So far, so good. Plus 5c1, which is what? 5. So I'm just going to take that out of here now. 5. 3a to the 4, right? Minus 4b to the 1. How are we doing? What's the next term? 5c2, agreed? 0, 1, 2, right? And then what is it? 3a cubed, 3a cubed,
Negative 4b squared.
negative 4b squared. Good? Okay so far?
Yeah.
5C.
5c3,
3a squared.
3a squared,
Negative 4b cubed.
negative 4b cubed. Plus
5c4.
5c4,
3a. Negative 4b cubed.
3a, oh, just 3a,
Yes.
so 1, yeah. Negative 4b, 4.
Simplify 5c4 to 5.
Yeah, we're going to get there. We're actually going to simplify this whole thing. And then the last guy is what?
5c5.
5C5 or 1, yeah,
which is negative 4B to the power of 5.
to the power of 5. So far, so good? Yep. Okay, 3 to the 5th is 243, is that right?
Yes.
3 to the 4 is 81, yeah, 343. So, what did I say? 243, right? Yeah. 243, a to the 5th, minus. Because it's gonna be a negative 4, right? So 3a, so I need 81 times 5, and times that by 4.
Is 4. 1,620.
And that'll be a to the 4th b. Right? Plus 27 times 16 times 5c2. What's 5c2?
10.
Okay, so 10 times 27 times
4,620.
4320?
Yeah.
Now notice what's happening with my signs.
It's
Yeah, every time the second value is an odd exponent, it's going to be a negative in front, right? Okay, so then the next one is 5c3, which is the same thing. So 10 times 9 times 4 cubed.
5,760.
Cool. Plus 5 times 3 times 4 to the 4th.
3840.
And then 4 to the 5th.
1024.
Okay. You guys okay?
Yep.
Brett? You sure?
Well, so how'd you get the 5760 and 3840?
5760 here.
Yeah.
So that's 5c3, which is 10.
Okay.
Times 3 squared, which is 9. So that's 90.
Okay.
90 times 4 cubed, which is 64. So 90 times 64. So you do all of these coefficients first with their correct exponents, and then times them by whatever the combination is in front.
Okay.
Good? Girls, okay? All right. Zach, good?
Okay.
Okay. Well, we're going to do a couple more, so then hopefully you'll feel better about it after that. All right. Next one. What is the third term of 5a squared plus 2 to the 6th? So I want the third term of it. Okay, so what's my k value then?
Sorry, 7.
No.
the k value is
I'm looking for the third term, right? So I'm going to show you exactly how I want to see you do this on an exam. And that's this. Tk plus 1 equals n ck a n minus k b to the k. So have it down beside you in front, right? So it's on your formula sheet. It's given to you. So I want the third term. So what is my k value? 2. So that's this. N is 6. So 6c2 5a squared to the, well, I always do the last term first, that's 2 to the 2, so that means this has to be 4. Okay? So I always put the k1 in first and then just make sure it adds up to give you the n value right there. So now use your calculator at this point. So 6c2 times 5 to the 4th times 2 squared.
37,500.
A to the 8. Okay? Good. So there's second way in which they can ask you. Make sense? Now here's the way I want you to look at it. It gives you a cubed minus 2 over a to the 7th, and it wants you to find the term that contains a to the 5th. So I'm going to show you a quick shortcut so that you don't have to do it all up. Now I don't know which term a to the 5th is. So my goal is to find out what a to the 5th is right now. Okay? So to do that, what's the very first, just worrying about the variables right now, what's the very first variable going to be here? What's my first term? A cubed to the 7, right? So that's a to the 21. Agreed?
Yes.
My second term is going to be a cubed to the 6 over minus 2 over a. Right? So what's 3 times 6? 18 divided by the 1 on the bottom is?
No, 1. 18.
No,
No.
because I got to subtract the exponents, right?
That was 7.
17. Okay, so what do you think the next one's going to be?
13.
13. So what I do is I check that math right now. A cubed to the 5th minus 2 squared like that, right? So that's a to the 15, and this is a to the minus 2 basically. So it's a to the
13.
No, yeah, 13.
13. Okay, so now what I do, once I have the first 3, what's your next one going to be? A to the 9, and then your next one's going to be a to the 5. What term is that? 1, 2, 3, 4, 5. So now I want to find the 5th term. Okay, so let's start this question again, focused on the 5th term. Okay, so what's my k value then?
4.
All right, so I've got 5c4 negative 2 over a to the 4, right? And then I have, what was it, a cubed to the 1. And now I simplify the term altogether. So I have 5c4 times negative 2 to the 4th. So that's 16. So 5 times 16.
Negative 80.
Negative 80? No. It's an even exponent. Therefore, you're not going to have a negative
Yeah,
value.
I didn't have brackets in that.
Okay. And then what's this going to be here? A to the 5. So there's your 5th term.
Why is it 5?
Yeah.
3 times 1 is 3,
Yes.
right? So what do we do wrong here? Should have worked. What did you do wrong? It's the 5th term, right? 1, 2, 3, 4, 5.
We'll change the
Oh,
A
because this
to-
isn't, this isn't 5, this is 7. Oh, this is the 5th term, sorry.
Yeah, that's
5th
okay.
term,
But your 1 should be 3.
that should be a 7. This guy should be a, what, 3?
Yeah.
3, 7c4. There we go. Okay, so I got 7c4 times, well, still, so it'd be 7c4 times 16.
516.
So it's 568. Not bad. Okay? So 7c4. Alright? So the easiest way to do this is to work out what the first 3 terms are so that you see the pattern. And then just keep going until you get what you want. Okay? Now, realistically, after the first 2, I could have got it. Right? You'd have made 3 mistakes, so that's why I say go to the 3rd one. And then see, make sure that it's still the same amount, and then just take it down from there. And find out what term it is, and then use your equations after that. Okay? Now on the exam, on one of the exams, they tried to trick you because they started with, they had a negative exponent. So you had to actually go down below, and then it actually came back up. I think the question was something like this. I had it was 2 over A, something like that, minus, maybe it was A squared. Doesn't matter. 2 over A cubed minus A to the 9, something like that. And then it asks for a specific term, which ended up being in the negatives, and you have to work the other direction. Okay, so you'd start, this one would be minus 27, would be your first value, and then your next one would be minus 25, I think, or something. So you work it back. That was the only way that they could throw a curveball in this actual question. And so when we look at the exams next week, we'll come up with how that works. Okay, so that's it. I'm happy you guys, there's only just the 2 working examples, and we're finished. So finish up chapter 11 today and tomorrow. What's today? Monday. So we could have if we tested on, let me shut the camera off. If we tested on, it's gonna be Thursday. Does that sound right?